One, you're going to understand and write identity matrices. You need to learn how to understand and write identity matrices. Second thing we'll do today is to find the multiplicative inverse. The multiplicative inverse of matrices, and we'll save 3 for next week because it's just a lot of work. So, okay?
For next week, we don't even have school.
We don't have Cabot.
It's the following.
Oh, I thought Cabot stuff matched.
Why would it? 2 different schools.
Last year.
No, it doesn't.
Yeah, it does.
No, it doesn't.
Uh-huh.
No, it doesn't.
It does.
No, it doesn't.
It does.
No, it doesn't times infinity.
Yes, it does. Times infinity square rooted.
No, it doesn't times. What? That makes it smaller.
Wait, what does that mean if it's to the 2? Up?
Just it's square.
Oh, square. Square.
No, it doesn't. Aleph null.
Okay, you lost.
That is a large figure.
Infinity?
You can't get bigger than Aleph null.
Huh?
Even Aleph null is bigger than infinity. You can't get there.
Aleph, no.
Aleph null.
I thought nothing was bigger than
No, Aleph null is bigger than
So then my
infinity.
teacher's been lying to me all this year.
Infinity is pretty large, but it's not as large as Aleph null.
Aleph, no?
Yeah.
What does
All right.
Aleph no look like?
An elephant. Oh. I don't know, but let's get started here. Let's understand the identity matrix and kind of the idea behind the identity matrix. Before we used to have, actually, I shouldn't say before we used to have because it's still around. Back when you were in Algebra 1, we talked about the identity property of multiplication. You guys remember that? What it meant was, like, if I took some number like 3 and I multiplied it by this identity number, I can get 3 back. Right? The original thing. And what was that identity number? It was 1. So we called 1 the identity. You understand that? So what we need to have with matrices as well is if I have a matrix, we'll call it A, and I multiply it by an identity matrix, then I'll get the original matrix back. Make sense? Okay, so let me get rid of this before it becomes permanent. So let's talk about identity matrix. The identity matrix looks like this for a 2 by 2. You guys see it here? I'm wiggling the mouse around there. You guys recognize what that looks like? It look 2 by 2. It looks like, I called it some special name, remember?
Oh, man. A box. No.
square matrix?
Reduced row. Thank you. It's in the form of reduced row echelon form. Remember, row echelon is with those zeros below, but this has zeros above as well. So this is in reduced row echelon form. So all it has is a diagonal of 1s, and everything above and everything below is a 0. So if I want to talk about the identity matrix for a 3 by 3, it should start off with 1, 0, 0, 0, 1, 0, 0, 0, 1. That is the identity matrix for a 3 by 3. If it was a 4 by 4, then I would have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1.
Wait, okay.
Here, all you really need to understand is that as this gets bigger for the identity matrix, we're just adding another 1 here. So we would get 0, 0, 0, 0, 0, 0.
Oh, okay.
So that's the identity matrix for a 4 by 4. Hence the notation for identity matrix any size. Right here. See it? It's just a diagonal of 1s every single time. Everything above is a 0. Everything below is a 0. That is the identity matrix. Questions there?
Wait. Don't change it.
Okay.
I feel like Sonia from Mortal Kombat. Gosh, I has like the blades in it. Just me.
Are we good here?
No.
Okay, I'll just keep it. It's like
Okay, identity matrix is what again? Is S1.
IJ.
Okay.
IJ, UJ, we all J.
I know what you say.
Oh yeah? Chase McKinley?
Yeah. I'm so mad. I feel like
Grr. Grr.
Ah, you failed that test, I failed that.
I feel that. No, she said I'm gonna feel the secret.
You failed the vertical line test?
Oh, I probably did.
I failed my driver's test once. I got my license.
I wasn't even supposed to take it. My dad made me take it because like you're already here so you can see what's on it. And I passed it.
Oh.
In your grade.
I didn't study.
Man, it's common sense.
What's common sense?
Your driver's test?
I failed it 2 times. Your driver's test? I passed both of them. Okay, so like.
Sounds like you're done. Here we go. So, here's an example of a 3x3. And here's the idea. If I want to get the identity matrix, it's simply going to be a bunch of 1s in a diagonal, 0s below, 0s above.
Why did you switch it?
We're not doing math with it.
That happens.
Did you want to do the math? We could do the math. I would love to do the math. Let's do the math.
Wait, so down. I just wanted to. I just wanted to copy down.
I'm going to make it bigger. There you go. Esteban.
I was kind of thinking to myself, but it ended up coming out. I'm sorry. It was an accident.
What is that?
I don't think that's a word.
Don't tell me lit isn't a word. I didn't know you were the dictionary police.
That was fun.
Oh, no.
That was fun. Shouldn't you be like, here, hold my hair?
Say something else.
Here, Blackwater, hold my hair.
Say something else.
Ow.
Say something else.
You look like you just got out of the shower.
Say hi to Cambria.
I wish I had like some Keisha nails. So you can record me.
Identity matrix for this is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, we're taking a matrix, matrix A, we're multiplying it by I. If that's true, and it follows the same ideas of the identity property, then if I take A times I should get A back, correct? So, huh? Mathemagic.
Oh my god.
Ready? Let's do this. Pretty mind-blowing, actually. So, we want the first row, first column. I'm going to use some different colors here. So I'm going to take this times that first row, or that first column, right? So that's going to give me a -2, 0, and 0. So guess what I get? -2. Look at that.
How do you get the same as same then?
That's a fantastic question. Notice the placement of the zeros and the ones. So when I do my multiplication, the only thing that really gets multiplied is the first value, isn't it? Do you see that?
Yeah.
Everything else becomes a 0, pretty much making the rest of this irrelevant.
Oh, okay, I get it.
And if I do that and I skip down to the bottom here, well, what's the only thing that's going to get multiplied, really? Not 5. I'm going to the next row. Next row. The 3 does, right?
Yeah.
And everything else becomes irrelevant. When I go down here, I'm going to multiply 1 by 0, and the rest becomes irrelevant. You see how that plays on that feature? So as I go over to the next column, let me clear this up. Because now I'm moving over to the second column, which is this column here. It plays on the same idea. I already took care of this first value, right? So I multiply it by 0. So all I'm really doing is multiplying the second item every single time, producing the list that just runs down here. 4, 5, 8.
It's like a Rubik's Cube.
It's exactly the same but different. But you see how the identity matrix works?
So then the next one would be
So the next one would just be it's pretty much the same thing. What I'm telling you is that if you take a matrix, multiply it by the identity, you're going to get the same thing back. You understand that? Simple concept? Good. Let's move on. Now, whenever we talked about the identity property of multiplication, Ashley, we also talked about another important feature, right? And that was the multiplicative inverse. Do you guys remember the multiplicative inverse? If I have 3, I'm going to multiply by something so that I get the identity back, which is what we call the multiplicative inverse. So in this case, what do I multiply 3 by? 1/3. So what you're doing is you're taking some number and you multiply it by its inverse, you'll get the identity matrix back. Questions there? So if I take a matrix and I multiply it by its inverse matrix, I'm going to get the identity matrix. Cool?
So basically it's just you're multiplying it by reciprocal.
No, it's not the reciprocal. It's the multiplicative inverse. They're very similar ideas, but they're not the same thing. Okay? Now, here's the problem. The problem is actually finding that multiplicative inverse. And that's what makes today's lesson time-consuming. I didn't use the word hard because it's not hard. You've already done this type of math. Okay? So I'm going to grab a matrix here. Here it is. Boom. Okay, you guys ready? This is how you go about finding the inverse matrix. The first thing you want to do is to augment the matrix, or the matrix you have here, with the identity matrix that belongs to it. So in this case, we should have 1, 0, 0, 0, 1, 0, 0, 0, 1. Correct? Now, it's through row operations that we're going to get the identity matrix. So how are we going to get the identity matrix? We're going to use row operations. You already know how to do row operations, right? We did that. You guys are like, oh, that's easy. Good. Now, here's what we need to do. We want this left side to end up looking like the right side. So what we're going to do is we're pretty much going to swap this. We need to get another augmented matrix where that right side is actually on the left side. And whatever is left behind over here would be called the inverse matrix. Questions there? You get it? You get the idea of what's going to happen? Okay. The idea is that I'm going to perform row operations on this top part, and at the end, once I have this side looking like the identity, right? I kind of swapped the position that we're in. Here's the identity right here, isn't it? It's on the right side. I want the left side to be the identity. Whatever gets left in here is the inverse matrix. So you guys ready?
Wait.
I'm going to get rid of this blue here. Oh, sorry, were you writing that? Here you go.
It's okay.
Button back. Smash. It's called Control Z. As in 3 snaps in Z formation. All right, so redo it then. Here we go. Luckily for us, this is already a 1, isn't it? So do I really need to do much there? No. So I'm going to do my tedious work here. 1, 0, 1. 1, 0, 0. Now, I need this 2 to become a 0. How am I going to do that? I'm going to take row 1 multiplied by a negative 2 and add it to row 2. You're lost?
I'm totally lost. I totally just lost you.
I want this 2 to become a 0.
Yeah, I understand that part.
The way I'm going to do that,
I thought we were going for the additive inverse.
we are. And how did I say we were going to do that? Through the process of row operations. So I'm in the process of making this side, the right side, because you can't see on the video, I'm in the process of making the right side look like the left side right now. Now if you notice, this was already a 1, right? So did I have to do anything there at this point? No. So what I'm trying to do right now, remember row echelon? Is to make those 2 zeros.
Okay, so we're just doing row echelon
For now, and then we'll finish up with reduced row echelon.
Okay, that's
Okay? That's kind of that's the plan. We have to reduce row echelon first, and then once we have row echelon, then we'll go reduce row echelon. Okay? So
Wait, we're not doing what we're just doing right now.
we are. I'll just explain to you how the plan. The plan.
That.
Yeah, we're not done. I'll just explain to Ashley what the, like I said, what the plan was. Okay? So let me delete that. Just go away. So here we go. Let's take row 1 and multiply by negative 2. That's going to give me a negative 2, 0, negative 2, negative 2, 0, 0. Correct? Okay, so I'm going to add those now to the second row, which is what I said I would do. So 2 plus a negative 2 gives me 0. Negative 2 plus 0 is negative 2. 1 plus negative 2 is a negative 1. Correct? So I've got these taken care of. And then I've got 0 minus 2 is a negative 2. 1 plus 0 is 1. 0 plus 0 is still 0. And the last row doesn't change at all. So 3, 0, 0, 0, 0, 1. Are we good? Okay, it was just one row operation for now, right? Can you guys see okay with this? All right. Any questions at this point? It's exactly like before, right? Just more numbers to multiply out and stuff? Okay, let's keep going. What's my plan now? What do I want to do? Make the 3 a 0. How? Take row 1, multiply by negative 3, and add it to row 3. Beautiful. So here's the numbers. Negative 3, 0, negative 3, negative 3, 0, 0. Correct? All right, cool. Let's do it. Does row 1 or row 2 change? Nope. So I'm just going to 1, 0, 1, 1, 0, 0, 0, negative 2, negative 1, negative 2, 1, 0. Here we go. 3 plus negative 3 is 0. 0 and 0 makes 0. 0 minus 3 makes minus 3. 0 minus 3 makes minus 3. 0 plus 0 is 0, and 1 plus 0 is 1. We're almost there.
Wait, so, like, I get how you have to, like, multiply it or whatever, but where do you get the number where you're supposed to multiply it? Like, negative 3, where do you even get that from?
Well, I want to add something to this 3, right? To make it a 0.
Oh, okay. So wait, you're trying to add the first number?
I'm going to use that because that's already a 1. And it's easier, right?
Yeah, but you always do based on the first number, or?
I always do it on the one that has a 1 above it. Because it keeps it cleaner and simpler. Because if that was a 3, then I would be like, ah, man, you know, what do I multiply a 3 or a 4 by to turn it into the opposite of a 3? That's tough, isn't it? That's why we like those 1s and those 0s.
So like, what if it was like that, but the 3 was a 0 and the 0 next to the 3 was like a 4 or something?
Well, I wouldn't worry about that yet. Because here, like right now, this is kind of situation, isn't it?
Yeah.
Okay, it's not exactly what we need, but I'm going to try to get that diagonal of 1s first. Okay, so now at this point, I really need to make this -2 a 1, don't I? Well, that's not bad. I use the multiplicative inverse. I'm going to take row 2 and multiply it by -1/2. Right? When I do that, does the top row change? No. So I've got 1, 0, 1, 1, 0, 0. Now the middle row needs to change. What's the -1/2 of 0? 0, right? What's a -1/2 of -2? 1. And then -1/2 of 1 is going to give me a 1/2 positive.
1.
No, it's not. That's -1 plus a negative. Oh, sorry, it's times. Okay, so it is. Negative makes positive, so it's a positive half. I was right. Okay. Now, -2 times that -1/2 is just a positive 1. Correct? And then 1 times -1/2 will give me -1/2, and finally 0. Oh, fractions. Don't be afraid of
I thought you
fractions.
said fried chicken.
Mr. Munoz, what,
That's how you know we played.
Monday,
Mhm.
you're gonna have tutoring, and we're not gonna have a test on Monday, right?
Says who?
I'm asking you, we're
Yeah.
not gonna have a test on Monday?
Are you prompting a response from me?
No, I'm asking you.
No, because you're saying we're not going to have a test, right?
Okay. Let me rephrase. Are we going to have?
Maybe.
Maybe.
Maybe not a test, because have we finished the chapter yet?
No.
But maybe a quiz of some sort.
Okay.
But kind of start off the quarter, be like, yes.
Quiz on Monday.
Yes.
So then after that.
Okay, let's finish this before we lose our train of thought. Okay? So right now, the last row doesn't change, does it? So that stays 0, 0, -3, -3, 0, 1. All right, cool. Everyone good here so far? Okay, what do I need to do now? I need to make the -3 into a 1. How do I do that? I'm going to take row 3 and use that multiplicative inverse again, right? So multiply by a -1/3, correct? Oh, that got sloppy there. So this doesn't change. This shouldn't change. And the bottom row should change. So the nice thing about multiplying by 0 is it's still just 0. There's my 1. Now, that's another 1, isn't it? And it's a 0. And then I've got -1/3 here. Correct? Are we good? Row echelon. Well, we're not there yet, are we? We need reduced row echelon. So that means we gotta go after these zeros up there. Now, before you have a panic attack, it's the same idea as we went downward for row echelon, but we're gonna do it upward now.
Trust me, I already have one.
Okay? So, remember how if we started with this 1, we would go down to 0 and then 0? Correct? So now that we have this 1, we're going to go upward, and we're going to go after this 1/2 and then that 1. Okay? So, here we go. Ready? What do I need to do to row 3 to get rid of this 1/2?
That's row 2.
Yeah, but I'm going to use row 3 to get rid of row
Oh,
2.
you're gonna use row.
Correct. I'm going to multiply it by a negative 1/2, and then I'm going to add that to row 2. Okay? You're going to have to think about that a little bit because now we're not moving downward, now we're moving upward. Okay? So for the reduced part, those zeros above, we're working our way up now. Okay?
Wait, but why would a negative half, wait, sorry.
I'm going after this right here. How do I get rid of a positive 1/2? By subtracting a half, correct? So if I multiply this whole row here, this row 3, here's the numbers I'm going to get. 0, 0, negative 1/2, negative 1/2, 0, 1/6. Correct? So now as I add those to row 2, see, row 1 doesn't change. So let's add them. 0 plus 0 is 0. 1 plus 0 is 1. 1/2 minus a half, 0. Which is what I needed. Now, let me get rid of those first 3. I don't want to get confuzzled there. So 1/2 minus a half gives me a positive 1/2. Negative 1/2 plus 0 is still a negative 1/2. And then 0 plus 1/6 is still 1/6. And the last row doesn't change, so 0, 0, 1, 1, 0, negative 1/3. We're almost at our REF, aren't we? Sure. What's the only thing that's missing? That 0 up in the upper right-hand corner, right? How do we make that? Add negative 1
Minus 1, or subtract 1.
to that number, right? But how are we going to achieve it through row of operations? Actually, you're thinking too much about it. Because if this was row echelon, you'd be all over it. We're going to use row 3. We're going to use row 3. I'm going to multiply it by a negative 1/2 again. Because that'll make this into a negative half, won't it? Oh, wait a minute, no. Just kidding. Thank you. Yeah. Good looking out. Row 3, I'm going to multiply by a negative 1. And then add all that to row 1.
So basically you're just gonna switch the sides and then add it to row 1?
Right, because that would make it the opposite of it, right? Now let's see what happens here. So I'm multiplying all this. It's pretty much just the opposite, right? So I've got 0, 0, negative 1, negative 1, 0, positive 1/3. Correct? And I'm going to add those values up here to the first row. So let me just start off with something like this. 1 plus 0 is 1. 0 plus 0 is 1 minus 1 is beautiful. That's what I wanted. So let me get rid of these 3 because I start losing my spot. 1 minus 1?
0.
0. 0 plus 0?
0.
0 plus 1/3?
1/3.
Okay. Now the other rows don't change, do they?
No.
All right, cool. So let me just copy them over. So I've got 0, 1, 0, 1/2, negative 1/2, 1/6, 0, 0, 1, 1, 0, negative 1/3. This, my friends, is the inverse matrix. But you see how the left side now looks like that identity?
Yeah.
But there it is.
Oh, yeah. Oh, geez. Can you go back? Definitely know what I'm doing.
It's the same thing, right? What's up? The right side is the identity matrix. How can you check it? How can you know, right? That's a fantastic question. Thank you for asking.
Can you plug it
Thanks for the assist. Plug it in.
in?
No.
I don't know. I'm
What I'm saying is that I started with this matrix here, correct? And what I'm saying is that this is the inverse matrix. So what I should be able to do is take a number, or a matrix, multiply it by its inverse, and I should get
The identity.
the identity. Now we're talking here. So, I'm going to get rid of this, cool? Because I know what that looks like. What was the original matrix?
1, 0, 1, 2, negative.
Let me erase all this. Does anybody have this written down already? So I can just write it over here? All right, cool. What is it? Whoa, where'd it go? Here. Stay.
Okay. Good again.
Okay. What's the original matrix? 1, 0, 1? Negative 2?
2. No, 2, negative 2, 1.
1.
And then 300.
All right, cool. So here we go. Here's the task. There's two 3x3s, right? And when I multiply them, I should get
You're not gonna.
a 3x3. What?
She's doubting you.
I love it. Non-believers.
I'm not gonna have non-believers, she said.
You sinners.
Oh, sorry.
Here we go. Okay?
Little heathens.
Shh, here we go. I should get a 3x3, right? So first row times the first column. Everyone ready? 1 times 0 is?
0.
0 times 1/2 is?
0.
And 1 times 1 is?
1.
1. What goes here?
Good job.
1. The sum of that. Add them up. Right?
Yeah.
Okay. I'm going to keep with that first column there, okay? 2 times 0?
0.
0. Negative 2. Half of negative 2 is? Negative 1. What's 1 times 1?
1.
When I add them up?
0.
3 times 0 is?
0.
0 times 1/2? 0 times 1?
0.
Add them up?
0.
Okay. Let's go over to the second column now. So now I need to get the second column of values. What's 1 times 0? 0. 0 times 1/2? 1 times 0? Add them up? So I get a 0 here. Let's go second column. 2 times 0.
0.
Half of 2
It's negative 1.
is a negative. Negative makes positive, doesn't it?
Oh, my
So it's a
bad.
1. So I got 0, 1. 1 times 0? Add them up. 3 times 0?
0.
0 times 1/2?
0.
0 times 0?
0. Man, this is so.
Let's do the last column. Let's do the last. Oh, that can't possibly be it, can it? 1 times 1/3 is 1/3. 0 times 1/6 is 1/6.
No, that's
That's 0.
That's 0.
Oh, good looking out. Good looking out. Good looking out. 1 times negative 1/3 is negative 1/3. So what's 1/3 minus a third? 0. 2 times 1/3, that is 2/3. Negative 2 times 1/6, that's going to be a negative 1/3. And then 1 minus 1 times negative 1/3 is a negative 1/3. So that's 2 negative thirds, right? Plus the 2/3 makes 0. 3 times 1/3 is 1. 0 times 1/6. 0 times negative 1/3. Drop the pen.
See, Mr. Lucas, that right there, that's the easy part. The other part, you're confusing.
Well, because that's multiplication, but what we did to achieve it was simply row operations. And that's, just gotta take it slow, because it does get confusing. First hour, if you look at the video, I missed a negative right here. See how I multiplied this by negative 1/2?
Yeah.
In this matrix, I just wrote 1/2 instead of negative 1/2, and I messed up the whole problem. So once I got to now, how did I check that? Right?
Yeah, bro, that's a good.
How did I know I found that I messed up? Okay. Truth is, I used my calculator. And I'm gonna show you how to do that. Okay. Let me clear this up real
Use the
quick.
bathroom?
You may. You're going to go over to second matrix, edit. Now notice my A is a 3 by 3. I put all of the values in from the original matrix in there. Okay? Simple enough, right?
Yeah.
Then I went second, quit, because this is where I do my math. Okay? I'm going to go second matrix again so I can find what matrix I'm looking for, which is A. And I took that to the negative first power. Like that, which is inverse. I push enter, and it spits out the inverse matrix for me. Okay?
That's a lot of things.
Now,
Lacey has a question.
go ahead. Can we do another one?
No.
Do we have time for another one of the questions?
Watch my model.
Your calculator failed? Oh, did you put in the right matrix?
I still can't do that on the computer. I like.
You put that in there?
I tried.
And these are all the numbers right there? Okay. So then you went second matrix. That one. And then see right here, Lacey? Right under matrix is x to the negative 1. Push that. And push enter. It's failing still? Let me see. And it could be because some of these older ones.
Oh.
No, you are using 4.
Wait, so you're. Why?
I think we talked to okay, because these are times like when me
I'm sorry, don't make me.
What did you do?
I did what I told you to do.
The same thing.
What?
I did the same thing you did.
Twice.
It's something about computers that scared of me and they'll function around me for some reason. I don't know what that is about. They break around you? Okay, ready to do another one?